Okay, two more examples and then you're going to be out of here with arithmetic series. So this one looks a little bit different and it has this funny little symbol here. It's the symbol called sigma. And hopefully you've seen this before. It's called sigma notation. And it just says evaluate the following sum. So if you're unfamiliar with this notation, basically what this means is this is the first number that we're going to be plugging in. We're going to start by plugging in a 1. So if you replace a 1 into this formula, that would give you the first term. So negative 3 times 1 is negative 3. Minus 12 is a negative 15. There's your first term. I call that u sub 1. Then you could do it with the second term, u sub 2, by just replacing this n with a 2. So negative 3 times 2 is negative 6, and negative 6 take away 12 is negative 18. Let's go one more. We're going to find u sub 3. U sub 3 would be the third term, and to get the third term, you just replace this n with a 3. So negative 3 times 3 is negative 9. Negative 9, take away 12 is negative 21. And you're going to notice this is becoming an arithmetic series because we are taking a negative 15, a negative 18, negative 21. It's just going down by 3 every single time. So it is arithmetic because it's got a common difference of negative 3. And you see that right there. We've seen linear functions before, constant rate of change. That's your constant rate of change right there, a negative 3, kind of like your slope. Now, we would continue doing this forever and ever and ever and ever, but it gives us a stopping point. We're going to stop at 48. So we're going to plug in a 48. So here's my u sub 48 after it goes on and on. If I were to plug in a 48 into that one, it would become negative 3 times 48, that's negative 144, and take away 12, that gives you a negative 156. So basically this is your starting point, plug that number in, then plug in every number up until here is your ending point. That's the last one that you plug in. And then what this symbol means, this sideways M called sigma, this means add them all together. That's what makes this a series, because that symbol tells us to add all of these. So we have to add this one, plus this one, plus this one, and everything in between. So hopefully we remember how this formula works. To find the sum of these 48 terms, we're taking n as the number of terms, which in this case would be 48. So we have n over 2 times the first term, that's negative 15, plus the last term, which is negative 156. And then we can simplify, that's a 24. And this becomes a negative 171. And the sum of all those 48 terms would end up being negative 4,104. So if you added negative 15 plus negative 18 plus negative 21 and so on and so on and so on forever up until the stopping point here, those would all add up to negative 4104. So that's kind of a little introduction to sigma notation. And first we had to realize because the formula looked like this, it looked linear, it became an arithmetic series where the common difference was negative 3. It was like your slope. So go ahead and try the next sigma notation on your own. And then when you're done, come on back for the last example. All right, I found out one thing that's kind of cool. As I'm changing colors, I have all those colors. I can swipe this way and I get some more like pastel-y type colors. I don't know, which one do you think is cool? I don't know, I kind of like this red here. So we're going to use this color, something new. So now we've got a series, negative 7 plus 3 plus 13. It's adding 10 every single time. And I want to find the value of n for which the sum equals 689. So basically I want to know how many terms do I need to have so that when I add them all up, it equals 689. So let's start with our formula here. So we have S sub n equals n over 2 times u sub 1 plus u sub n. And let's see what we can plug in here and replace. I'm going to pick a new color. We know that the sum is equal to 689, so I can replace this sum with 689. It's telling us to solve for this value of n. We don't know what n is, so we're going to leave that as n over 2. We know that u sub 1 is the first term, which in this case is -7. And then we get u sub n. I don't know what the last term is. So this last term, u sub n, we had another formula that we can replace u sub n with. So if you remember from the last arithmetic sequences video, u sub n is just equal to u sub 1 plus n minus 1 times your common difference d. So I'm going to replace u sub n because I don't know the last term in this series. I'm going to replace u sub n with this formula. So if I replace this u sub 1 here, that's going to be -7 plus, here's n. Again, I don't know what n is. That's fine. Leave it as n. And I do know the common difference is 10. So the key here was I didn't know the last term. If I don't know the last term, I'm going to replace it with that formula. And now you'll notice we're down to just one variable. So we have one missing piece of information, and that's the n. Let's change colors again. That one looks kind of cool. Seafoam green. So now we're going to simplify this mess in here. So this remains 689 equals n over 2 times, if we combine these, that's a -14. We'll distribute that 10 to both of those, so it's plus 10n minus 10. We can simplify it a little bit more. And if you combine -14 and -10, I'm going to rewrite it with the 10n first, but this becomes -24. Now, however you want to solve this from here, it's completely up to you. There's a bunch of different ways that you can. I'm just going to distribute this. So we are going to do 689 equals, if I take n times 10n, that would be 10n squared, but then divide it by 2, it becomes 5n squared. And similarly, if I take n times -24, it's -24n, cut it in half, dividing by 2, and that's -12n. So all of a sudden, we've got this quadratic equation once again. So let's go ahead and make this side equal to 0. And we're left with 0 equals 5n squared minus 12n minus 689. Now, you could solve this, you could try factoring, but I'm guessing most of you probably don't know the factors of 689 very quickly off the top of your head. We don't even know if that's going to work very well. So let's not stress about factoring in this case. You could complete the square. We probably don't want to do that. So let's just go ahead and use the quadratic formula. I'm going to trust that you know how to do that, and I'll save you a little bit of time. We get n is equal to, you get two answers. One of them is a decimal. You can't have like a decimal for a term number, so ignore the decimal. You do get a whole number, and that's n equals 13. So that would be your final answer. You could also go to Desmos, and you could graph these with x's here, and then just find the x-intercepts, and that would also give you a 13 for your value. So however you want to solve those, that's fine with me. Just recognize it's quadratic, and you have to know that you need to solve it somehow, and you get 13. So go ahead and try that last one on your own, and then when you're done, you can move on to the next set of notes on geometric series.